In this video, we're going to be having a look at a particular form of trigonometric function. So in order to get into this form, let's just consider 3 cos x plus 4 sine x. Now it's 2 terms, and ideally, if we were going to solve an equation or do something useful with it, it might be better if it was 1 term. So the question is, how can we bring these together? Let's have a look at the graph of this function. So, we'll get into the right mode on the calculator and graph. And we'll graph 3 cos x plus 4 sine x. And now we've graphed it, we can see that it's looking like a periodic function. It looks, in other words, rather like sine or cos. So if we look at the little ticks on the y-axis, we can see that it's approximately 5 high on the peaks and approximately 5 deep on the troughs. So, if it looks like cos or sine, let's graph cos x. So there's cos x ploughing along. We can see they both look periodic. And what we want to do is to change cos x into what we had to begin with. So let's remember that the height of the peaks was 5 and the depth of the troughs was 5. So let's multiply cosine by 5. So we'll graph 5 cos x. And what we see is we've got an almost exact copy. It's just displaced a little bit. Things are happening a little bit too soon. Okay, that being the case, how much too soon? It seems to come, if we look at the ticks on the x-axis and look at the distance between the 2 peaks, we seem to be about 1 unit on the x-axis early. So let's correct that. And let's graph 5 cos of x minus 1. And that's almost correct. It's just covering over the graph and making it a little bit thicker. So it seems that we can write this as 5 cos x minus 1. Now, my calculator was working in radians, so this 1 is 1 radian. 3 cos x plus 4 sine x is 5 cos x minus 1. Well, 3, 4 and 5 are a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. So that kind of says to us, if we had any function a cos x plus b sine x, could we bring this function, these 2 functions, together as one function like that? And if we did it, would the number that went in front be the square root of a squared plus b squared? Cos of x minus something, let's call it alpha, and then what is alpha? Okay, all we've done is some graph work and made some guesses. What we have to do now is work with algebra and work with our trig functions and our trig identities to try and see if this little bit here at the bottom can actually be made to work. So that's our next step. So let's start with where we want to end up. A number r multiplying cos of x minus alpha equals r. Now, cos of x minus alpha is one of our addition formulae. So we can expand it as cos x cos alpha plus sine x sine alpha. Let's multiply out that bracket. R cos x cos alpha plus R sine x sine alpha. Now I want to rewrite this so it's very clear what I am multiplying cos x by. So here I am multiplying cos x by R cos alpha, and I'm multiplying sine x by R sine alpha. So let's make that very clear. R cos alpha times by cos x plus R sine alpha times by sine x. And what we want is that this should be A cos x plus B sine x. In other words, this R cos alpha will be A, and this R sine alpha will be B. So we can make that identification. R cos alpha is A, and B is R sine alpha. Now, how can we bring these together? Well, one way is to notice that cos squared plus sine squared is 1. So let's square this one, A squared, square this one and add the two together. A squared plus B squared is R squared cos squared alpha plus R squared sine squared alpha. And there's a common factor of R squared that we can take out, leaving us cos squared alpha plus sine squared alpha. This is one of our basic identities. Cos squared plus sine squared of the same angle is always 1. And so that gives us R squared. So the thing that we said was a possibility, in fact, is a result. That if we take A squared plus B squared, take the square root, we do indeed end up with R, the number that goes in front here of the cosine. But what about the alpha? Have we got enough information at this point here to find alpha? Well, let's write these two equations, A equals R cos alpha and B equals R sine alpha, down again. But this time, let me write them above one another. So, we'll write these down again, but this time, I'm going to write one at the top and the other one directly underneath. And by doing it like that, it suggests the possibility of dividing this equation into this equation. And so we have B over A is equal to R sine alpha over R cos alpha. We can divide top and bottom by R, and we're just left with sine alpha over cos alpha, which we know is tan alpha. And so now we can work out what alpha is, because alpha is the angle whose tangent is B over A. So, what we've got now is that we can write any expression of the form A cos x plus B sine x as a function which is R cos x minus alpha, and we know that R will be the square root of A squared plus B squared, and that alpha will be the angle whose tangent is B over A. And that is a very, very useful tool to have at one's disposal. It reduces two trig functions to one trig function. Makes it so much easier to deal with. So, let's have a look at how we can use this to solve equations. and also how we can use it to determine maxima and minima of functions. So we'll begin with an equation. Root 2 cos x plus sin x equals 1. Now if we compare this with the standard form we've been working with, a cos x plus b sin x, then a is equal to root 2 and b is equal to 1. So we can calculate r. R is the square root of a squared plus b squared. So that's the square root of root 2 all squared plus 1 squared. Root 2 all squared is 2. 1 squared is just 1. So this is root 3. So what we've got is now r cos of x minus alpha. So we've got root 3 cos of x minus alpha equals 1. And what we have to do is we've got to work out what alpha is. So we know that tan alpha is equal to b over a. And so that's 1 over root 2. And so we need to know, what does that tell us about alpha? Well, one of the things we haven't specified is what's the range of values of x and what units are we working in. So let's say we're going to be working in radians and that we want x to be between plus and minus pi. So if x is in radians, then alpha's got to be in radians. And we'll now bring in the calculator in order to work that out. So I want the angle whose tangent is 1 divided by the square root of 2. And that angle is 0.615. Lots of other figures, but we'll stop there for the moment. Radians. So now, I know what r is, and I know what alpha is. I'm not going to write down 0.615 for a little while. I'm going to keep it as alpha. But the equation that we're now trying to solve is root 3 cos of x minus alpha is equal to 1. And we know that we want x to be between pi and minus pi. So let's have a look at what is this cosine. Well, to do that, we're going to divide both sides by root 3. And so we have cos of x minus alpha is 1 over root 3. So what is x minus alpha? Let's just draw a little graph to help us see what we're looking at. Between plus and minus pi, the cosine graph looks like that. There's plus pi, there's minus pi, this is minus pi by 2, and this is pi by 2. So we're looking for two answers across here. Come down to there. So let's have a look for one of them, and our calculator will tell us this one here. So the angle that I want is the angle whose tangent is 1 divided by the square root of 3. And that is 0.955. Now if that's 0.955 there, remember our calculator will give us this one then the other one by symmetry is minus 0.955. Well, now we've got x minus alpha. What we need is x. So this will be x equals 0.955 plus alpha, or minus 0.955 plus alpha. And if you remember, alpha we calculated as 0.615, so we can write the value of alpha in and work out these two values of x. So we add these two together, we're going to get 1.570, and if we take these two, we're going to get minus 0.340. So if we work to two decimal places, that's 1.57 and minus 0.34 radians. So let's take another example. This time we'll have cos x minus root 3 sine x is equal to 2. And we'll take x to be in degrees and between 0 and 360. Okay. Well, slight difference here. We've got a minus sign and not a plus sign. So let's see what this means. A must be equal to 1 because we've got 1 cos x, and b must be equal to minus root 3. And this is going to make a difference to what happens. Let's leave it on one side for the moment and go ahead with our calculation. R will be the square root of a squared plus b squared, which will be the square root of 1 squared plus minus root 3 squared. Well, 1 squared is 1, minus root 3 squared is 3, so it's the square root of 1 plus 3, which is 4, and so R is 2. So what we've got now is 2 cos x minus alpha equals 2. And we can divide throughout by this 2 to give us cos of x minus alpha equals 1. This should be relatively easy to solve, provided we can work out what alpha is. So what is alpha? Now remember, we calculate alpha as tan alpha is b over a, which in this case is minus root 3 over 1, which is just minus root 3. This is a problem to us. It's a problem because previously all the answers have been positive, and we have had positive A and positive B, and we've gone straight for the first quadrant. Let's just remind ourselves what we mean by quadrant. I'll write down again tan alpha, which is calculated as B over A. Let's just remind ourselves what these are. They are sine alpha and are cos alpha. And in this question, they're minus root 3 over 1. Revise what we know about quadrants. This is the first quadrant, the second quadrant, the third quadrant, the fourth quadrant, going round anti-clockwise. Now, in the first quadrant, all of our trig ratios, A for all, they're all positive. In the second quadrant, only the sine ratio is positive. In the third quadrant, only the tangent ratio is positive, and in the fourth quadrant, only the cosine ratio is positive. Now we have tan alpha is minus root 3 over 1. So it's negative, which means that we must either be in the second quadrant or the fourth quadrant, which is where tangent is negative. So we have a choice to make. Our angle alpha is in here or it's in here. Let's have a look what we can see from here. Our sine alpha is minus root 3. Our cos alpha is 1. That means sine alpha must be negative and cos alpha must be positive. And it's in this fourth quadrant where cos alpha is positive and sine alpha is negative. So our tan alpha is minus root 3 is in here somewhere. So let's draw a picture, this time looking the same perhaps, but where's the angle? Well, we've got to have minus root 3 and 1. And this is our angle here, alpha. So that what we can see is that if tan of alpha is equal to minus root 3, then alpha must be equal to, now the angle whose tangent is plus root 3 is 60 degrees. So this one must be minus 60 degrees. Okay, we've got alpha sorted out. Let's just remember what our equation was. Our equation we had got down to cos of x minus alpha was equal to 1. So now we need to put these two pieces of information together to help us solve the full equation, help us find the value of x. So let's turn over and write these down. Alpha, we know, is minus 60 degrees. And we're looking to solve the equation cos of x minus alpha is equal to 1. And we know that x is to be between 0 and 360 degrees. So let's sketch our cosine curve between 0 and 360 degrees. We know that it looks like that. There's 360, there's 180, and here we have 90, and here 270, just squeezing that in there. We know that this goes down as far as minus 1, and these maximum points are up at 1. So what we can see there is that the angle whose cosine is 1 is either 0 degrees or 360 degrees. So x minus alpha is equal to 0 degrees or 360 degrees. What is alpha? Well, it's minus 60. So x minus 60 is equal to 0 or 360 degrees. That's x plus 60 is equal to 0 or 360 degrees. And now we can take 60 away from both of these. So x is minus 60 degrees or 300 degrees. Remember, the original range of values of x was between 0 and 360. So this is not an answer, minus 60 degrees. This one is the only answer within our range of values of x. So x is equal to 300 degrees. Let's turn over. Now, let's have a look at what might be termed a calculus type example. In other words, a question that's going to involve us with maxima and minima. So, what about this function? F of x is 4 cos x plus 3 sine x minus 3. What are its turning points? What are its maximum and minimum values? Well, knowing what we do know from the previous work that we've done, we know that we can express this bit, 4 cos x plus 3 sine x, as 5 cos of x minus alpha, and then the minus 3, where tan alpha is 3 over 4, b over a. Now, this function is now very easy to deal with because we know all about a cosine function. The maximum value of cos is 1. Never gets any bigger than 1. And so the maximum value of f of x is, well, it must be 5 times by 1 minus 3, which is just 2. And when does that occur? Well, let's think. The maximum value of cosine is 1 when the angle equals 0. Well, in this case, the angle will equal 0 when x equals alpha. So very quickly we found out exactly where this maximum value is, exactly at what point this function f of x has its maximum value. What about the minimum value? The least value? Well, let's think about cosine. The least value of cosine is minus 1. Never goes any lower than minus 1. And when does that happen? That happens when the angle is pi, or 180. So what we know there is that the minimum value of f of x must occur when this is at its minimum, in other words, minus 1. So it will be 5 times by minus 1 minus 3, which is just minus 8. And when will that happen? It will happen when the angle, x minus alpha, equals pi. In other words, when x equals pi plus alpha. So very quickly, and with a minimum amount of work, we've established a maximum value and a minimum value. And based upon this information, we could go ahead and rapidly sketch the curve. So again, we see that this form, r cos x minus alpha, is a very powerful form for us to know how to use and for us to be able to formulate from expressions such as 4 cos x plus 3 sin x. It's a form that you really do need to work with and a form that you really do need to practice. Initially, it's not so easy to get your mind around, but it is possible to do so, and it will pay great dividends if you can.